Welcome to the joint blockchain and AI vlog from members of the OECD's AI Policy Observatory and the OECD's Blockchain Expert Board. Together, the groups were central contributors to the content of the OECD recommendation on blockchain and other DLT and the OECD AI policy principles. The principles and recommendation are among the world's most important Web3 policy framing documents. They represent the first binding intergovernmental legal standards of how public and private actors can work to create future-ready, cohesive, and compliant global systems. They provide a blueprint for nations to follow in the journey to safely unlocking the potential of humanity's next great technological leap forward. We're also bringing these OECD conversations and expanding on them through our X vlog. That series is called Odyssey. Our guest today is Dr. Leemon Baird, the founder of Hedera Hashgraph and the founder, CTO, and co-CEO of Swirlds Labs. He is a legend in the space. We're delighted to have him for our conversation today. My name is Benjamin Yablon. I am mostly focused on the blockchain and DLT side of the OECD work and have been contributing quite a bit on the AI side. This year, I'm the founder of a project called Orbu.ai, which is a prediction market powered by human intelligence and AI. I'm joined today by my co-host, Cyrus Hodis, who will give a brief introduction and launch into our interview with Dr. Leemon Baird. Cyrus, take it away.
Thanks, Ben, and thanks, Leemon, for being with us. As I mentioned, you're very excited about this call. Briefly, my background is AI and tech and policy. I've been working with the OECD AI since its inception, since the beginning, and that came up with the OECD AI principle that have been adopted by the G20. So really giving a global angle to these principles. And I'm also working at the intersection of AI and blockchain. I've started a new company called AI GC Chain, where we are working on a multimodal generative AI platform that has a very strong responsible AI angle, leveraging blockchain for traceability, transparency, etc. So I'm going to jump right in and ask you the first question. I mean, it's really to give us an overview of Hedera and how it's different from the other blockchain and DLT protocols.
So it's different in the way that it works at the bottom layer. The actual consensus algorithm, the math of it is different. And it's also different in that it's better governed. We have a different governance model that a lot of people resonate with. So these are the two main differences. At the bottom layer, we have the math that makes it extremely fast while also being extremely secure. It's asynchronous Byzantine fault tolerant, which is something no other major ledger even has. These other DLTs and blockchains don't have that. But what it means is that it is guaranteed that all the nodes will come to an agreement. It'll be the same agreement. They'll never change their minds. It's immutable. And it is hard for bad guys to stop that from happening, even if they can control the internet. That's what the A in ABFT means, asynchronous. Even if they can do various attacks on the internet against you, they still can't stop us from coming to agreement. That's the ABFT. And then it's also better governed, which means we have a council of 29 of the biggest top 10 universities in the world, Fortune 100 companies spread around the world in different continents, under different governments, in different industries, and they all have an equal say. They do on-chain voting, and they each have 1/29th say in what happens with Hedera. They're each a 1/29th owner that has a 1/29th vote in what it does. And so it is well governed, and it has this unusually secure system that is extremely fast, which also makes it inexpensive and also makes it low carbon footprint.
Excellent. I think that there's quite a bit to dig into here, but we'll stay at a surface level for the moment. Who would you describe as the typical users of the Hedera platform? And could you give us a bit more information around the Hedera Council, which you were just getting started with, but that's of keen interest to us and really dovetails very interestingly with the work Cyrus and I have done on the policy side. So the way Hedera is set up is almost a brilliant use case of what could potentially serve as a blueprint for a lot of other use cases. So please jump in.
Yes, so we have lots of users, enterprises, small businesses, little startups, individuals using it, a wide range of users. The enterprises are very interested in it because it is well governed. That's a reason. Also, it is very fast and very inexpensive. And in fact, the prices are priced in dollars, not in the cryptocurrency. So as the price of cryptocurrency goes up and down, you still have predictable costs for your company. And so a lot of people are interested in that, as well as the governing council. And we try to do everything the right way. We try to be very, very conservative in everything that we're doing. And so that makes it very appealing to enterprises. It's very appealing to the green industry, people that are doing carbon credits and green energy, because first of all, it's green itself, very low carbon footprint, but also we have all sorts of tools to make it very easy for you to tokenize carbon credits and do other things. So it's a wide range of users.
Great. So I mean, to delve into the sustainability aspect of Hedera, can you address a bit the energy consumption model?
Yes. So University College of London had a report on the energy consumption by all these different ledgers from Bitcoin down to Hedera, and how much energy it uses to do one transaction. And Hedera is vastly below everybody else. The next best ledger was 20 times worse, and Bitcoin is many billions of times worse. Even Visa, when you swipe your Visa card, you're using 1,000 times more energy for that to be processed through the whole system, 1,000 times more energy than a transaction on Hedera. And so it has been appealing to people because it's inherently green by using very little energy, very little carbon footprint. But then for that little bit we use, we buy carbon offsets so that we're carbon neutral. Then we buy a few more so we're carbon negative. And so it's good to be carbon negative, but it's even better to not use that energy in the first place. And so that's really one of the reasons that people like it. Also, though, it's just very fast and inexpensive and predictable pricing, all the things you'd want in a carbon credit token market. And so that's another reason that that's kind of gravitated to Hedera.
Yeah, that dovetails really well with the next question, which was really focused around the speed and throughput of the system, how large it can scale. And then it's, I know your background is very much around computer science. You've chosen to focus here, but I think that you've got probably quite a bit to share on the machine learning side. So later into this, we'll delve into what Orbu is looking to achieve, why Hedera is such an interesting protocol for this project as well. But first and foremost, speed, throughput, and how large can it scale?
Yes. So right now we have slowed down the network to a mere 10,000 transactions per second, so which is huge. And we can make that faster. If we ever get close to 10,000, we'll make it 20,000. We'll make it higher. Eventually, it gets too big for you to do in a single shard, and then we'll go to sharding. And sharding is where you have lots of little networks that talk to each other. The interesting thing is that because Hedera is ABFT, that super high level of security, it is possible to have messaging between the shards that causes the big system of the many little networks talking to each other as a whole to be ABFT. And so, of course, with sharding, you have infinite scaling. As many transactions as you get, that justifies having that many shards. But you retain the security. Because the individual shards are so secure, the whole thing is secure and incredibly fast and will be very inexpensive. So we scale very, very high. And this is because of the algorithm itself. It sort of inherently goes at the speed of the internet. There's some sense in which you can't get any faster than kind of what's inherently in it.
Right.
And so that's why it's so fast.
So just a follow-up question before you ask your next, Cyrus. I don't think that we asked this at the very beginning, and we probably should have. Can you differentiate Hedera and the methodologies you use under the umbrella of DLT versus what people traditionally refer to as a blockchain like Bitcoin? So the graph versus the more traditional technology stacks that people think of when they hear blockchain.
Sure. So the word blockchain is used two different ways. One definition of blockchain is a DLT. So we're a blockchain. We're an unusually good blockchain. Another definition of blockchain is a particular way of reaching agreement where you have a chain of blocks. Each block has a bunch of transactions in it. They build up one on another. In the oldest systems like Bitcoin, it's proof of work. And so who gets to put the next block on the chain? Well, there's a contest. And it's whoever can burn the most electricity is basically what it is. Not ideal. People then the world has been moving to proof of stake. Bitcoin is still proof of work. but others like Ethereum have moved to proof of stake. We're proof of stake. Proof of stake says you don't have your privilege by burning electricity, you have it by staking the coins. And so you don't have one person becoming millions of nodes because they can't afford to. There's a cost to doing it. Far better, you don't waste electricity that way. So we're proof of stake. But the interesting thing is that we don't even use the proof of stake to force them to okay, now it's your turn to put on a block, and now it's your turn to put on a block. We don't do that. What we do is every node is pumping out blocks as fast as it can at the same time, not worrying about the order. And just in every block, you have to put in 2 little hashes that remember the last block you created and the last one you received. That's all.
Right.
You do that. You just spread them around as fast as you can with gossip. And when someone collects a big pile of these blocks, they can snap together like puzzle pieces because of those hashes and form a structure. And you can just look at it and know what the order is. And so they all get put into an order, just like an ordinary blockchain, but it's not built that way. It's built where everybody does it at the same time, total chaos. And then with zero further communication, everyone looks at their pile of messages and just knows what order they go in, and we're done.
So beautiful chaos.
Beautiful chaos.
Before jumping to my next question, I have a follow-up on this one. The adoption of the Hedera network is very impressive. It went further than the use of Ethereum. Can you address that also briefly?
Absolutely. So we're the most used network right now. We have 1,000 transactions a second that are going through the system. And these are real transactions, not part of doing consensus like some other people might count. These are actual transactions, far more than any other ledger. We've processed 22 billion, 23 billion, I don't even remember. It keeps changing frequently how many billions we have processed, far more than any other ledger. So we are very widely used. And we are used with people doing tokenization. And then we have smart contracts. And then we also have this way that you can store information, the Hedera Consensus Service. It's like a notary public service where you can immutably store information. And it costs you 1/100th of a US cent to send a message through that will be stored forever, a 10,000th of a US dollar. And you pay in H-bars, the cryptocurrency, but it's not denominated in H-bars. So you have predictable pricing. So incredibly low and incredibly fast. People have been using this to prevent fraud. They were using it for tracking of supply chain. They're using it for provenance. What is the history of a given item? Lots of different things.
I mean, we're talking about governance, Ben and I think, this would be the perfect tool for government to use, keeping the ledgers there. Since you have a background, we didn't really talk about your background. You have a very impressive background on AI also, and Ben mentioned computer science. But you understand AI technology very well, to say the least. I would love to hear your take on open source versus closed source. The debate rages now. The last company I co-founded is Stability AI, which is really promoting the open source angle. I have a lot of friends in the AI safety community who are pushing back on that. Love to hear your thoughts on this.
Sure. So everything we have is open source. All of our code is open source. The code on the mainnet is open source. The code on our mirror nodes that store information forever is all open source. People are running those. All the tools that we've built, huge number of tools, huge number of SDKs, they're all open source. Not everything in the world should be open source, but I think it's useful that we're open source. And I think that this makes it easier for people to use it and to look at it and to appreciate it. At the very beginning, we were bootstrapping. We were open review, where you could see the code, but now it's just ordinary open source, Apache 2 across the board. But even the open review was important because everyone could see what is running. Now everybody can actually see it, and you can run it yourself. We have local node where you can download it and run your own little Hashgraph network, your own Hedera network, or something like Hedera, just on your own. I think that's important. In the AI world, this is interesting. We have a mixture of open source and non-open source. AI is going to have a pretty big impact on the world, and I am happy to see the open source projects in the AI world. I don't think it's evil to do a proprietary system. I think that there are roles for proprietary systems in the world. If someone's working, they should get paid, and some business models need that, not all. But I am very happy as a citizen of this planet to have open source versions of AI, because in some sense, it's too powerful to lock up in just a few companies. We really need it to be open so that we can avoid some of the pitfalls of AI. But that maybe is a different interview.
Right. So you're not worried about very strong AI system being in the hands of everyone, that can use them for nefarious reasons.
Okay, the cat's out of the bag.
Right.
Everything was published long ago. If you want to build a transformer, you know how to do it. If you want to build a convolutional neural network, you know how to do it. That's been published in the literature. The cat's out of the bag. If you're worried about bad guys building AI, bad guys will build AI. That's whether it's open source or not, it doesn't matter. On the other hand, the good guys that can't afford to build a big AI system do benefit from having it open source. And I think we're in a world where we don't have a choice of whether to keep the genie in the bottle. Okay, it's out of the bottle. We don't have a choice about that. The best we can do now is make sure as many of the good guys as possible get it, because the bad guys already have it. And so I think this is closed source would not be an argument on the basis of there are bad guys that might get it. Sorry, they've already got it. It's too late. We might as well just push forward and try to come to a future that has AI. It's not an option to have a future without AI. That's no longer an option. So what we want is not a dystopia, but a utopia with AI. We want to have the good future with AI, not the bad future with AI. And I think open source actually helps us in that.
I think those are really salient points. And the debate rages on, and it does so sometimes in an information vacuum, unfortunately. What are the barriers to adoption as you see them currently and in the future, both to blockchain and open AI systems? What are educational resources that you recommend, and what are you seeing from Hedera's perspective on ways to speed adoption, but in a sensible way? So back to a piece of what Cyrus's question is around AI safety standards. We will do these pieces of work with different governments, with the OECD, et cetera, and having these laws on the books are only a very small component of this broader conversation because of the speed that these things are going. So that's a long-winded question, but I think that the spirit of the interview is such that your honest answers on barriers to adoption are a key concern of mine.
So we'll talk about blockchain, then we'll talk about AI. But
Great.
in DLTs, the biggest barrier to adoption perhaps is lack of regulatory certainty. This is worse in some countries than others, but it is something the whole world is struggling with. It is critically important that the industry be regulated in a way that allows it to exist, and that you know what the rules are. There is enormous effort that goes into trying to guess what the rules might be. Oh, that's bad. You have to know what the rules are. They should be told what the rules are. It should be unambiguous what the rules are. For anything you could do, you should absolutely know, is this legal or illegal? This is very important. And the industry is hurt by lack of regulatory clarity. And when we get regulatory clarity, of course, the regulations need to be such that they will not strangle an industry that could really be a huge boon to mankind. Humanity may immensely benefit from this industry. So don't just strangle it. But you also want to protect consumers against fraud. And you also want to protect against other sorts of nefarious things. And so there's always this balance between let's make sure nothing bad ever happens, and let's make sure good things can happen. And you have to have both, and you have to balance it, and you have to be clear, and it has to be unambiguous, and it has to be self-consistent. It also helps, this is inherently a worldwide thing. Ledgers aren't as useful if they're confined to a single country, because the trust comes from spreading out. And so it's helpful if the world can agree on regulation as well. All of these things. For AI, the biggest problem at the moment is the whole issue of where your training data comes from and how you get permission for it, and what kinds of permission you need, and what kinds of royalties you owe to the people that you got the data from. And what does it mean to put something on the web and say it's free to the world? Well, maybe it's free to the world, but not entirely free if it's being used as training data. There's an enormous list of questions here around data. And in fact, these two entirely separate worlds start to overlap now. Well, how do you manage your permissions on your data? Maybe you use a ledger that's managing permissions. This is a big deal. There's people doing this on Hedera for medical permissions. Can my medical data be used in clinical trials? And exactly how can it be used? And can I revoke it? All of that uses the ledger, where we need to do the same thing for AI. We need to make it very clear what permissions are for training, and then have micro payments, which crypto can help with this, back to royalties, maybe to the person who provided the data, all sorts of things. So I'd say that's the number one problem on blockchain side, DLT side, and the number one problem on the AI side. And I can list others too. Both of them just have to be easier for the average person to use. And there's lots of other issues we can talk about. But I'd say those are the number one problems on the two sides.
Excellent.
But unfortunately, within the AI community, I noticed that there is a lack of adoption, to say the least, of blockchain because of the bad rep that crypto gave it, which is very sad. But both Ben and I are working at the intersection of AI and blockchain with Obu, leveraging AI, collective intelligence, and blockchain for market predictions and AI safety, with AI GC chain, leveraging blockchain for traceability, ownership of data, ownership of models, ownership of output. So we both convinced that there is, a very strong linkage there. So you mentioned that, a bit already. You touch upon it, but we'd love to understand also, how do you view in interaction between both these powerful emerging technologies, AI and blockchain? Are they separate? Are they linked? You gave one example, but if you can dig into that a bit more.
Sure. So I gave the example that dealt with maybe the biggest problem in AI right now, but there's other examples too. So there are generative systems that help you answer questions about how to use a blockchain.
Mm-hmm.
And so for Hedera, there are generative systems out there that will, if you have questions about, well, how do I write code to do this? How do I build an app to do this? How do I interact with the mirror node? And how do I interact with the mainnet and all these things? There's generative AI now systems that have been trained that are able to answer your questions, and people find it useful. You can even go a step further, and I've seen systems for this, where the generative AI is generating the transactions. Now, you never want it to just submit the transaction on your behalf without you seeing it. Hallucinations are a thing. There is a sense in which our current generative AI systems don't know what they're saying. But what you can do is you can have it generate what its best guess is as to what you want, and then show this to you and have it explain to you in non-AI code. Have non-AI code that puts it on the screen, non-AI code that tells you briefly what this transaction is going to do. And so you tell it some vague thing, some complicated thing, it magically creates this really detailed transaction. And then you look at it and you say, yes, that is what I want to do. And then you click the OK button and it happens. So right now, that's a way that AI can even do things for you on a DLT, submit transactions for you, but only with the human in the loop. At this point, you don't want to do it without the human in the loop. That's important.
No, please finish.
Okay. Yeah. And as you pointed out, my background was in AI. I started in machine learning, and we can talk about that if you're interested. That was reinforcement learning and designed for deep neural networks. Convolutional neural networks is what we called it back in the 90s. Some of this stuff has been around since the 90s, but then transformers and diffusion are more like 5 years old. So it's kind of exciting. Some of this stuff is decades old, and some of it's just brand new. So that is a way that AI works. Another thing that AI can do is you can have it look at, say, the code of a smart contract and look for bugs. And you'll never find all the bugs, but you can find some bugs. And people keep losing millions of dollars because of bugs in a smart contract. It drives me nuts. Or bugs in an app that uses a blockchain or a ledger. This is crazy. So AI may be able to help with that. When you're writing it, of course, AI can be helpful in writing the code. Again, I would never trust code written by an AI, but my developers say that they find these AI tools incredibly useful. Copilot or whatever, they will write a little block of code and then you have to go in and fix it. It's not always right and doesn't know what it's doing, but it's helpful, and they actually find it faster to use the AI to write the code than not. And then, if you want one more intersection, which you didn't ask for, but I think the future of computer science is formal methods, where you have a computer program and you have a math proof that it is correct. You didn't just test it with all the testing cases that you could think of. You have a math proof that it will work in all cases, and that certain classes of bugs are guaranteed to not be there. And the Hedera uses hashgraph consensus. We have a math proof that I wrote in the style and published, peer-reviewed, in the style of a math journal where humans read it and see the math proof. But Carl Query, a professor at Carnegie Mellon University, turned that into a form that the computer can check. And he did it. This is really hard, but he actually did this. He put it into a form that the computer can check, and it checked and found that this consensus algorithm truly is ABFT. And the next step is now have it look at pieces of the code. This is very hard to do, but it's worth doing. My hope is that we're going to get to the point where AI combines with these proof assistants to make it fast enough and easy enough that it can be widely used. and that every smart contract can be done this way. All the code on mainnet of the ledger itself can be verified this way, where you have a math proof, humans maybe do the big steps, and then all the little steps get filled in by an AI. And we can use reinforcement learning for that because it can learn from trial and error because the proofs checker tells it whether it did a good job or not. I love it. You don't have to worry about training data. The training data is free.
Very exciting stuff. And yeah, I think that you were someone that Cyrus and I were really excited to have a conversation with, because obviously you're a significant leader on the DLT side. You're very well known for Hedera, but from your background, you have quite a lot to say and a dramatic impact to have on this burgeoning AI conversation. And the biggest piece of the AI conversation, whether it should be or not, revolves around safety and runaway machine intelligence, AGI, on and on, the stuff of sci-fi or maybe the stuff of reality. Cyrus and I aren't here to opine on that per se, but we do think a lot about safety standards, not from the perspective of trying to pass a law that says this is what safety standards are and this is what ethics are, but around the mechanical integration of technologies to constrain the behavior of these systems. And so that's really kind of at the core of what Cyrus and I have been working on at Orbu. And one of the reasons we're very excited to talk to you, and I've engaged with Hedera on a couple of early pieces of this project. But for all of the reasons you're kind of highlighting, the throughput of Hedera is massively important when we're talking about systems that need to operate in real time and with enormous amounts of data. So the energy implications are profound, and the throughput implications are profound. And I think the combination of those over time are where we'll see robust safety systems being embedded into these, rather than a group of bureaucrats attempting to bolt on these systems, or a conglomerate of technologists. It's a lot of what you're saying, and being able to hard code these directly in and then let them operate in the wild, so that the data sources themselves aren't of concern. The things are mathematically proven to do what they're supposed to. So very, very exciting conversation. Appreciate you taking the time to be with us. I'll jump into the next question, not ramble too much. We're here to listen to you, not Cyrus and I. So we're looking at differentiating the societal implications of the deployment of DLTs for governments, and the ups and downs of the crypto market, and how that's kind of been a turnoff. Can you highlight a bit of what Hedera's work with governments has looked like, and what sort of engagement you're getting on that front?
Sure. So we talked to lots of people. Governments should be interested in DLTs for a number of different reasons. First of all, they have to decide how to regulate it, and not over or under regulate it, not badly regulate it, not ambiguously regulate it. Governments can also be using this for some things, like if you want your data to be obvious to the world, clear to the world, and immutable, and you can be trustworthy, then ledgers can actually be useful for the government. Governments talk about CBDCs, which is maybe they set up their own stable coin. Why would you do that? Because then that allows it to interoperate with the existing ledgers. And then all of these efficiency gains. I mean, the entire GDP of a country can be improved by the efficiency gains that ledgers are going to bring. And so anything that makes the on-ramp and off-ramp easier would be good. And CBDCs are part of that story. Central bank digital currencies is a way that governments can have their currency easily move on and off of a DLT, which is one of the sources of friction. But this allows us to have much more efficient stock markets, or the equivalent, or even markets for things that today would be such a pain that we don't even have markets for them. But in your supply chain, you can have markets with your suppliers, little tiny markets that are fair, and are secure, and are going to do the right thing because it's guaranteed with the ledger. There's all sorts of places where you can eliminate the middleman. You can use the ledger. And so governments should be interested in this because they also have supply chain. And they also have information. They also care about the provenance of things. And then also they need to be encouraging this in industry because it brings efficiencies that will make them better. And if a country is slow to embrace this industry and tends to crush it, it will move elsewhere. And the benefits will accrue elsewhere and not to that country that is behind.
Yeah, definitely. We've seen quite a bit of that, and I haven't lived in the U.S. for a couple of years now, but have regularly traveled back and seen the kind of the status of regulation, and it's slow and unfortunate. And then watched places like Bermuda develop very, very quickly and move on to the next phase of what their economic growth trajectory is going to look like by embracing sensible regulation and onboarding good actors. So you're seeing it happen in real time, where places where a lot of this really interesting IP was developed have chosen to move it other places where they can actually go grow it and have an understanding of what the regulatory landscape is. But Cyrus, I didn't mean to jump in on your question. You're supposed to take the regulatory question.
So yeah, I mean, there's a vexing situation right now, as you're very well aware. The pace of innovation of emerging technologies, true in blockchain, even truer in AI, doesn't catch up with the pace of regulation. Regulation actually don't catch up with innovation. Do you have ideas, solutions, how to address this gap?
So how can regulation catch up? It needs to bring in inputs from experts that understand the system. Anytime there's a new system evolving rapidly, you need to truly understand it to regulate it well. You can look at examples of regulation in other markets that are different. So, what is a cryptocurrency? Is it a money? Is it a commodity? Is it a security? Or is it a new kind of thing that has properties of all of them? I think it's a new kind of thing that has some properties of all of them. So look at how these were all regulated and then come up with something rational for this new thing that in many ways resembles old things, but is actually maybe a new thing. And so come up with those, get everyone involved in this, and then think carefully. We want to prevent bad things, but also encourage good things. And don't lose either half of that puzzle. You need both sides of this. And think carefully about your regulation. What are the unintended consequences? Or is it going to allow bad things that you didn't think of? And is it going to crush the good things that would have happened otherwise? You need to think about both of those very carefully. And then we need clarity. So even if it's just a safe harbor and it says, okay, for a few years, in this little piece, we're not regulating and you can do anything, but we guarantee we won't get mad at you retroactively. Even something like that is a stopgap measure is okay. But we just need clarity so that people know what is it that I'm supposed to do right now and what am I not supposed to do right now. We definitely need clarity as well.
I mean, you start with the point of education, which is crucial. For policymakers being able to address this, they have to understand it. Unfortunately, it's not even the case. It's not often on their radar. Colleagues at Stanford High are looking, at educating Congress. I mean, there are initiatives around the world toward that, but I think that's the first step to be able to address this gap for sure.
Definitely. So you got into a little bit of a really interesting topic that I think our viewers would like maybe some more detail on. So central bank digital currencies have been a topic of conversation for quite a while now, but that conversation is heating up very quickly, and you're seeing in the U.S. I've seen some legislative initiatives to completely ban it, and then in other jurisdictions, China has had a living, breathing example of it for quite a while, and there are justified fears. And then there's a whole lot of noise and fear mongering that goes on. I think the key fear that people have of CBDC is related to a tool of control. This ability to attach a social credit score to a digital currency that could be turned on or off. It's on and on. So without opining on the politics of it, what I would ask is from a design perspective, what sorts of features can Hedera enable that would make the policy, give the policymakers control to enhance privacy, or to custom tailor these solutions to make them palatable?
I understand. So it's funny. What does CBDC even mean? People have pointed out that most of the dollars in the United States are ones and zeros in the banks of the Federal Reserve. It is a network of computers that maintain ones and zeros, remembering the dollars. Well, isn't that a blockchain? But it isn't. It isn't resilient against one of them being malicious, but you could say, well, hopefully we have good enough security on all those computers. It also isn't a DLT in that it isn't interoperable with the other ledgers. And so I think that some people say, well, we already have a CBDC. Okay, great. But what we would really like is a CBDC then that is able to interoperate easily with other ledgers. So a dollar in the Federal Reserve computer could become a wrapped dollar on another blockchain. And that would really be the key of how it would differ from what we have right now. Then you could say, well, what about privacy concerns? Well, the Fed dollars are already tracked. They go to banks, and the banks track who has the money in their bank account. And so we already have tracking of all that with strong KYC AML. I'm not sure that that really changes much. You could say that when the dollar moves to the ledger, then it could become anonymous. And there's one of the big debates is, do you track everything on the ledger as it's moving around, or do you track it at the endpoints? Do you say it can be anonymous as it's going around the world, but when it comes into a bank or a store in my country, then my country regulates it? And so I kind of lean towards saying that if you regulate at the edges, it works better than regulating in the middle. But that'd be one of the things that has to be decided. That's one of the big debates that has to be
definitely. So just to follow up on that, digital identity has also been a huge topic of conversation. Do you see an interplay between the promise of what a self-sovereign digital identity could bring into this conversation as it relates to CBDC? Maybe some of your more articulate thoughts on digital identity and the Hedera ecosystem. And Cyrus, sorry, I don't mean to keep stealing your question.
Please.
Where are we going to go?
So let's talk about identity even more broadly. Identity is critical across all of these things that we're talking about. It's even critical in the AI stuff. It's critical in the CBDC stuff. What I envision is that we can actually get to a future that has better AML and better privacy at the same time. There's this tension between the two, but I think we can actually improve both as we go to the future. So you talked about self-sovereign. The idea is you have all of your own information. So my name and my address and my history and my social security and everything else, I have it. It's on my phone in a secure chip or something. It's ones and zeros that I have. And if I need to interact with you, if I need to prove to you that I'm over 21, I don't have to show you everything. I don't have to show you my birth date. I can just do a zero knowledge proof, a crypto thing with you that proves to you that I'm over 21 without telling you my age, or proves to you that I'm a citizen of the United States without showing you my home address or my social security number or anything else. Or it can even prove to you that I'm a citizen of one of the following 10 countries without telling you which of the 10 countries it is. So this is self-sovereign. And then there are places where we have KYC AML, right? Know your customer, anti-money laundering. There are needs of regulators to know who you are when you do certain things. And it is even possible to have strong identity set up such that they can know who you are on a given transaction later, but only if they say get 2 different government organizations to digitally sign something. It's actually possible to set this up. So there's no one person in the government that can look at it.
Very powerful. And immense. I think it's arguably one of, if not the most powerful humanity expanding components of what this technology stack can do. Solving digital identity and the AML KYC meltdown should be priority number 1. And I've sat in working groups as part of the OECD work with the Financial Action Task Force. So FATF obviously has a lot to say on this and help set the policies globally for how these things interoperate. I know their eye is on it, but I'm wondering if you've had interactions there with Hedera, or if that should be on the short list of projects to be bringing toward you.
Okay, so identity is one of the things that Hedera is very interested in, is doing a lot of work with, working with other people on identity solutions. Identity on top of Hedera is important because it enables everything else. And identity is just incredibly important. Things like, here's an example. My bank account right now, I have to tell the bank who I am. They know everything about me. And then they report to the government what I do, at least with big transactions. And the government, when I say the government, that's not a person, that's a whole organization. But there's a lot of people in that organization where a single person could see all that data. We could actually go to a system where my bank doesn't know who I am, but they still give the information to the government. And the government is not just some random guy in the IT department that is able to see it, but it would actually take 2 different departments to agree to open it up. So maybe the FBI and the court both have to agree and digitally sign something. So it's not just that legally they have to agree, but actually technically they can't see who I am until that happens. And then they can see what I'm doing. There's a
Right.
way, there are ways to do this, but we have to have these identity systems. They have to be interoperable. We need to get passports and driver's licenses to interoperate with these, so that we can have identity that interoperates with those. So governments really need to be pushing it with that. I should be able to get on an airplane with just my phone. It's stupid for me to have little pieces of paper or car or plastic to get on a plane. That's dumb. It should all be on my phone, and it could be more secure and more private and better tracked for the government when they need to, but better checks and balances on when they need to. We can actually make this current system better at each step along the way. There are trade-offs, but we can make it better on both sides and still have the trade-offs, but improve both sides.
Very, very well put. Cyrus, do you want to land this plane? I've got a couple more questions. Yeah, please. No,
You're gonna land it.
We're not up against a hard stop, and this is a fascinating discussion. So please, what occurred to you?
Just a quick question on the regulated sandboxes. You know, they use and they emerge actually from blockchain ecosystem in fintech. That's something that we're looking at more and more in AI system and deploying AI system. As you said, the cat is out of the box, so we didn't have that approach quite put together as we were launching this strong generative AI system. But we'd love to hear your thoughts on this. Could this be applicable to AI, and how?
So I'm not sure what a regulatory sandbox exactly entails, but it is important that we, again, not jump the gun and have regulations that crush things without understanding them.
Mm-hmm.
And so, for example, in the self-driving car industry, it's good to say, here are the rules for when you can be on the road. You want to maybe not go a whole lot into the details of putting rules on what the software looks like. But you do want to say, I need you to convince me in some way that the car is safe before I let it drive itself. I mean, that's what the government should be doing. And so I would say that you want to be very careful. Don't go trying to micro-regulate how the software works, because it's evolving so fast and so complex, you're probably going to get it wrong. But do micromanage deciding when you allow self-driving cars on your road. And that's just one example. Of course, this is true all across AI. AI has great potential for good and great potential for evil. And you want to make sure that we don't accidentally destroy the world, but also that we don't crush the good that can come from it.
Definitely. So I think that partially answers the question on sandboxes, because they were very popular a few years ago as a tool that regulators could deploy. So regulatory sandbox is a special purpose license that can be given out to a fintech company that gives them, without the regulator needing to understand exactly which laws are tripped by the product. They're able to have a regulator, and they're not operating in a gray zone. Unfortunately, what that effectively does as well is add another layer of complexity to the regulatory journey, so that I think they've somewhat fallen out of favor recently. In terms of regulation and where these things head, some predictions for the future would be a good way to start bringing this toward a close. I do have a couple of other questions for Cyrus, though, that from a bit earlier in the interview, Cyrus, you had a comment about stability AI and generative AI generally around the dangers. And one of the things that you had pointed out to me was the idea of a bad actor using generative AI to create some sort of a bioweapon, et cetera, as one of the things that the proliferation that would be problematic. So I'm not sure that we really closed off that piece of it. And what sort of technological components would you see to answer that question, Leemon? So it's this open source versus closed source conversation. Just to put it in really stark relief for people, how would you prevent something like that, where somebody's generating the ingredient list and being able to mix up something nasty?
And maybe how we can leverage blockchain.
Leverage blockchain to prevent it as well.
Okay, so we have this problem without AI as well. Lots of very nasty viruses have been sequenced, and it's published, and you can get the base pair sequence anytime you want. And there are machines you can buy that will print any sequence of DNA you want. So anyone can create anything in their garage. AI might make that worse, but it's pretty bad even without AI. And so we're going to have to try to track these things, to see what people are creating in their basement with biotech. That's a scary thing.
Right.
I think that we have a real concern about an AI getting onto social media and being used to sway people on social media. We already have problems with bad actors drawing people into bad areas. And now you could have a single person with an AI acting like a million bad actors drawing people into it. And you have an echo chamber where there's lots of voices. Well, all the voices are one person running AI, but they sound like lots of voices and very convincing. You have deep fake videos that people can see some horrific thing happening and blame the person doing it. And the whole thing is fictitious. And in the long term, people need to just learn not to trust video anymore until it has been digitally signed by someone you trust. But it's going to take a long time, I think, to get people to get to that point.
So that's almost like a proof of reputation or a digital identity conversation as well, right? So to deal with, you could still have pseudonymous avatars, but the base identity would need to be verified and tracked somehow, and that would be a significant step to combat exactly what you're describing, which is very troubling, right? The ability to sway public opinion using social media peaked. We're still in the middle of it, I suppose, but that's, I think, another brilliant use case that needs to be highlighted for the public. And the purpose of these interviews that Cyrus and I do is to shine a light on, dispel the FUD and shine a light on what's actually possible with this and under what timeframes. And that's, one of the final questions that I would ask would be around your predictions for the future. But prior to that, Cyrus, anything you wanted to jump in on the generative AI side? I know that's you're a founder in the space and a pretty significant voice there. So don't let me steal all the generative AI thunder.
No. I mean, we discussed it, touch upon it. Leveraging blockchain for the identity, proof of ownership, traceability, transparency is a fantastic tool, and it's totally being underused right now. So in the near future, our hope here and I is that these tools are going to be used and applied. But yes, we'd love to hear also your views on the future, prediction for the future on both technologies, to close this discussion.
I am very optimistic. So I see lots of bad things that can happen along the road, but I think that we're going to end up in a good place. I am optimistic about this for both blockchain and AI. So DLTs clearly are going to change the world. They're going to make the world more efficient. They're going to enable new use cases you just can't even do today. It'd be too hard to do today. They're going to make things more reliable, more secure, faster, cheaper, enabling new kinds of things. AI is going to touch every area of society in very fundamental ways. I have some concerns about any rapid change in the economy and the way the world works is extremely painful for some people. In the long term, I think it's all good, but we need to somehow minimize the pain as we get there. And there are lots of downsides, like we just talked about a case where generative AI is not inherently evil, but until people understand the threat, they're going to believe any video they see. Okay, that's a problem. And so eventually we learn that we live in a world with AI. But for a while, we live in a world with AI and not understand that we live in a world with AI. That's a problem. And so I think we really need to work hard on all of these pitfalls in the short term. But I am optimistic that in the long term, we end up in a world where everyone is vastly better off than we are today. And I could talk a lot about how AI is going to change the world and a lot about how DLTs are going to change the world. But I think it will materially improve the lot of everyone on this planet, including third world people who are unbanked, who are now getting access to banking services through DLTs. And some of the banks on our council are doing that. And AI is going to enable incredibly cheap, high quality products for everyone. Even the very poorest people will be able to afford them. It's a bright future. We just need to minimize the bumps along the way. And there are real threats along the way. And we just need to work very hard on those.
Outstanding. Thank you, Leemon, for taking the time to do this interview with us. Really tremendous insights. And I think we would definitely like to have a follow-up interview with you, maybe a little bit more focused on some of the specific AI applications that we discussed today. This was very high level, but got, I think, deep enough that our audience is going to get quite a bit out of this. So thank you again, Cyrus. And anything else from your end?
No, I really appreciate your time, Leemon. That was very informative. And yes, looking forward to furthering this discussion in the near future also.
Well, thanks a lot. I really enjoyed talking with you. And so thanks.